In this video, I'll talk about a projectile which is thrown from a height at an angle theta towards the ground. So let me explain it. So you have a projectile here, and this projectile is launched at an angle theta towards the ground, and the velocity is given, the angle is given, and this height is given. Now you need to find out what is the horizontal distance, what are the horizontal velocity and the final velocity when it reaches to the ground. And you need to also find out the angle, and at the same time you need to find out how long does it take to reach to the ground. Okay, so the given values in this case is theta is given, which is 45 degree, and the initial velocity is given, which is 10 meters per second. We know this angle and we know this velocity, so the x component of the velocity would be v0 cosine theta, and the y component would be v0 sine theta. So v0x, which is a cosine component, 7.07, and similarly v0y, v0 sine theta, if you plug in, you'll get 7.07 meter per second. Now let's calculate the time of flight. How long does it take to reach to the ground from this height? Okay, and to make life a little easier, or for our sake of convenience, I'm choosing this point as my origin. This is my x-axis and the downward is my y-axis. You may choose in any way you like to, but you should be able to write down all the other variables with proper sign. Okay, so I'm just using this kinematic equation. Y in this case is the final height, y0 is the initial height, v0y is the initial velocity, t is the time, g is the acceleration due to gravity. So the final height, when you launch from this height, then the final height would be this height. This is the final height, which is 2. And the initial height, that is it is starting from 0, which is 0. v0y, which is the initial vertical velocity, would be 7.07 times t, half, g value is 9.8 t square. Now I'm just rearranging this equation. If you divide 9.8 divided by 2, you'll get 4.9 t squared, 7.07 t, and then if you change the side, you'll get negative 2. So this is a quadratic equation. And if you solve the quadratic equation using this formula, what you get is time is minus 1.69 second and 0.24 second. Here, what does this negative time means? Can the time be negative? Physically, it's not possible. No. But mathematically, it does make sense. What is this negative time means? You might ask, or you might wonder, what does the negative sign means? If it does not make sense, why it is physically even coming into this equation? Or why it is a part of the solution? There is the sense. Let me explain this one. So here, we're launching the projectile at an angle theta in the downward direction. Now, if we have launched the projectile at an angle theta in the upward direction, okay, in the upward direction, then this velocity component will be in the upward direction. And in that case, the time it would take to reach to the ground would be t equals to 1.69 second. And in that case, this would be the negative time. So that is, in this problem, although it does not make sense, but it does have a meaning that if you have launched the projectile at an angle theta in the upward direction, then this time would make perfect sense, or this would be the time, or it would be a part of your solution. Okay, but for this particular problem, this is the only feasible solution for our problem. All right, now let's calculate the horizontal distance. the horizontal distance along the horizontal motion, there is no acceleration. The reason is the force is only acting in the downward direction, which is the force of gravity, as there is no force acting along the horizontal motion or horizontal direction. The acceleration along the horizontal would be 0. So now we're going to use this equation here again, which is a kinematic equation. The x is the horizontal distance. In this case, we have r, which is the horizontal range. The v0x is the horizontal velocity, which is 7.07. And the time, we already have calculated this time here, which is 0.24 second. Half acceleration is 0 along x-axis. So the horizontal distance that we have gotten is 1.7 meter. All right, so that's our horizontal distance. Now let's calculate the horizontal and vertical velocity at the ground. Well, the one answer you know, of course, is the horizontal velocity would not change. So even at the ground, the horizontal velocity would remain exactly the same, which is vgx equal to v0x, and it would be 7.07 meter per second. Now let's calculate the vertical velocity. This is now for the vertical direction. Vertical direction. Okay, so this velocity is the final velocity or the velocity at the ground, and this velocity is the initial velocity at which it was launched in the y direction, and g is the acceleration due to gravity. So here I'm writing the final velocity at the ground, and this is the initial velocity, g, and the time. We need to calculate this one, and the initial velocity is given 7.07 plus g is 9.8 times 0.24. And the reason we have chosen here plus is because the speed would increase if the velocity is in the downward direction. So we got 9.42 meter per second, and the direction, as this is a velocity, the direction would be vertically downward. Now let's find out the angle, this angle now. This angle, how do you find out this angle? So in order to find out this angle, if you look into this triangle here, into this triangle, okay, let me redraw this one. It's not exact. So let's say, okay, I'll just draw here. So let's say this is your horizontal velocity, which you call v at the ground, x, and this is the vertical velocity along the y direction at the ground. Now this is your velocity at which it hits the ground, the v, and we call this angle as a theta or alpha. So how do I find out the angle alpha? Now if you look into this triangle here, then the tangent alpha would be this. The tangent alpha would be right over run. So right is vgy over run is vgx. That's how we find out the tangent alpha. So exactly, I'm using the same equation here. The tangent alpha is the y component divided by the x component. The y component is 9.42 and the x component is 7.07. So the alpha is 53.1 degree. And the speed, when I say speed at the ground, this is the speed at the ground. What is the magnitude of this velocity? That is the speed. And if you look into this triangle, this one would be the hypotenuse. So by Pythagoras theorem, you can simply calculate it by using this formula here. Vgx squared plus Vgy squared. Vgx is 7.07 and Vgy is 9.42. So this is the not the velocity but the speed or the magnitude of the velocity at which it hits the ground. So this is it. So what I will now recommend you to do is do exactly the same problem, but not at a 45 degree, but at 30 degree, and write down your answer in the comment section below. Okay. And again, at the end, do not forget to share, like, and subscribe the channel.